This is the network prioritization tutorial for scGRNdb. Let's go to the Explore Networks in the top nav bar here again and click on the network prioritization to learn more details. So this pipeline identifies cell type networks that best model your input gene sets. The required inputs include a gene set file, a species that matches the gene naming convention in your input file, and one or multiple single cell atlases to model your gene set against. And the outputs include your prioritized cell type networks and their enrichment scores for your gene set of interest, and ready to run key driver analysis for mergeomics. And you can also visualize them in the scGRNdb network browser. Let's go ahead and start running the pipeline. So here you can choose a human sample set, which is a cardiovascular disease gene set. Same with the mouse, using the mouse naming conventions, or you can upload a file that just has to match this table format with a module column and a genes column. And the module column is just a name for your gene set. I'm going to go ahead and use the cardiovascular disease gene set provided in the human sample. Choose human. And for atlases, for non-brain tissues, we recommend using Tabula sapiens or human cell landscape. And then you can put in your email if you like. When I click submit, you're met with a progress page that includes a link to this exact session if you decide to close the browser. And it's also emailed to you if you provide your email. I've gone ahead and finished running this in another session, so we can go ahead and take a look at that. If you come over to this analysis options here on the sidebar, you can actually view the details of the form that you just submitted, and you can download the enriched cell type networks and their enrichment scores on this download button here. It can take some time to gather all of the data sets, output results. There we go. But you can also visualize that exact same table directly in the browser. Here is a list again of all the different cell types, and you can search by different columns using in this search pane. Here, if we're interested in liver, for example, you can click liver, and again you can sort them by different columns as well. If you expand any of these rows, you can see a bit more information about this table or about this row exactly, including the false discovery rate, the risk ratio or the enrichment score for this network module for your given gene set, as well as the overlap and the gene set size. Now, I'm interested maybe in the liver hepatocyte and the liver macrophage. We can actually go ahead and click these and select them for KDA here, using the select for KDA. And this will prepare all of the input files for KDA and then give you direct links to go straight to those key driver pages on the mergeomics pipeline. It'll auto-populate the input form for you, which includes the pathway, your network, and you can use the default parameters here. For more information on this pipeline, you can also go to the mergeomics tutorial on this website. You can go ahead and run the pipeline, and I've also gone ahead and run this pipeline already for the liver hepatocyte network, and you'll get these key driver results that you can again download. And here again you'll see the key drivers that best model your gene set of interest. Beyond looking at just the key drivers, we can visualize these networks by clicking the Visualize button for any of these rows that we are interested in. When I click Visualize, you're brought back again to the network browser, and it'll zoom in onto the module that is enriched for your gene set. Here I can look in the pathway enrichment. This is cardiovascular disease, looking at a liver hepatocyte network, and we can see a lot of pathways that relate to liver function with respect to cardiovascular disease, including coagulation and fibrinolysis. Now let's say we also want to compare the other cell types in the liver that were also enriched for these gene sets. to understand their role in cardiovascular disease. So I'm going to visualize the liver macrophage as well. That'll pop up on the side for a side-by-side comparison. The module 7 is particularly enriched, and here we see the main pathways include a lot of immune signaling pathways, which is very fitting for the macrophage function. One small thing is you can expand the visualizations of any of these networks by clicking the full width, and then I'll put them top and bottom. But you can also shrink them and be able to compare them side by side. What I'm going to do now is visualize each of those modules here. Right, we can visualize these modules like this. And one way you can actually compare them side by side is also by using this combined networks, which is part of the network comparison tool. Because these are two different cell types, and they're explaining different functions, we don't expect any of them to be shared, but if they were shared, they would be in green. Network 1, which is the liver hepatocyte network, is in red, and the macrophage network here is in blue. Again, you can filter very similar as to the network browser to the top percentage nodes for each of them. You can get a direct comparison more readily in this way. So yeah, that's it for the network browser or network prioritization, and then we'll move on to network pathway annotation next.